So let's welcome my boss, my helper, Miss Faith. The floor is yours.
Thank you very much, Mr. Ken. I appreciate. Thank you guys for the opportunity to be here to mentor. Um, I'm believing that by the end of this session, we should be all badass in writing Cairo Smart contracts and building amazing stuff in the space. Also adding value to ourselves when it comes to this. All right, so let's get into it. Today's class, I'll be doing like a three-phased kind of class. We'll first be dissecting a smart contract from the Cairo book and also dissecting the smart contract when you set up a new um, project to work on. And then finally, we'll write one ourselves. So without further ado, let's get into it. I'll be sharing my screen now. So we begin. If you have any questions or feedbacks or whatever, what have you, just please type it in the chat box while the class is going on. Okay, so please, can I see some emojis if you can see my screen? Okay, thank you. Thank you very much. All right. So I'll be dissecting this smart contract with us all so we understand how a smart contract is the whole architecture of a smart contract. Here, this is a simple smart contract, and what this smart contract is comprised of is what we call these use Starknet contract address, called get caller addresses. These are like pre methods that are already in the Cairo compiler for us to call, so you can see them like little libraries or like parent contracts we are reading from to give us these functions implementation in our own project. So when you are importing anything into your smart contract, any predefined library, any predefined method from the Cairo compiler that you would be needing, this is where you import it at the top of your project. Just like your regular smart contract, your imports are always at the top level of your smart contract. The next thing is we have to define our interface. We all know what interface are, right? So we have to define our interface called traits. And how we do that, we create the skeleton of our functions that will be called, that will be used in the context of the smart contract in this interface. So called the function signature. The function signature is the function, right? The function with the function's name, and then the argument, the parameters the function has. So you declare it here, and then later on in your implementation of this function, you can implement what these functions should do for you. So you create your interface using this macro to highlight you are about to set up your interface, you're about to start your traits. And then it is name traits, the name of the traits, and it is for a contract. So it is taking this, what do you call it, feature as a contract state. Now, we have these two functions that will be implemented later on. The first function is a get owner function and self t contract state, and then you are calling a contract address. You are expecting to receive a contract address at the end of the day. So this here is your entire function signature for this particular function. What we are expecting this function to return is a contract address. So anytime you see this arrow, it means you are expecting this function to return something at the end of executing itself, or at the end of it being run. So anytime you call this get owner function, you are expecting a message to be returned, the contract address, because this should be the owner of this contract. Now, also notice that in this get owner function, we have this self here, and it is self or T contract state. These contract states that we have initially featured right here, we are taking on this feature, this characteristic. And so what this means here, anytime you see self, it means this function is a read function. It's like a snapshot of what is already existing in the storage. Okay, so when you see this self at T contrast state, it means a snapshot of what we already have in the storage. So this function, judging by this feature over here, it's a read function, because you have the self and you have the snapshot. You're snapping, you want to get this contract, this current contract state. You want to read from this current contract state and get the owner of this particular contract. And you know that this owner means it's a contract address. So you're getting the address from this contract, which is equivalent to the owner who owns the contract, who deployed the smart contract. Okay, I hope that is clear. And then we have the second function, signature, transfer ownership. And at this point, we are doing reference self at T contract state, and then we have a parameter. Now, what this function is doing is, because you have this reference here, it means you are referencing this smart contract. You want to make a change in this smart contract. So what that means, this function having this reference self and then the T contrasted without the at it means you are trying to make a change. So this is a write function. When you see any function like this having these characteristic, it is a write function, while this is a read function, because you are taking a snapshot of what is already in storage and you are not making any change to it. You're only reading what is already there. While for reference self, T contract state, it means you want to get the current state of the contract and make an edit to it. So you are changing the state of the contract. And when I say state, I'm sure you all know what I mean. A state can be from 0 to 1. If something is 0 and then you perform an action on it and then it shifts, it gets an addition and becomes 1, it means you have changed the state of that thing. If you push something from left to right, you've changed the state, because it is no longer at the previous state where it was stationed before. So anytime you use ref self, it means you want to make an edit. You want to create, you want to write to the blockchain, you want to create a change in the state of what is currently there to be something entirely different. Now, after you declare this, the next thing is to pass in the parameters that will be needed for this function to be implemented. And this parameter is just one parameter called new owner. Mind you, the name of this function is transfer ownership. So it means you want to transfer the ownership of this contract from whoever this function is going to return this contract address to a new contract address. And this new contract address, excuse me, is whoever you added here to be transferred to. So this new owner is also a contract address because the owner has to be an address. And that is why you see that this has been imported over here. So you can easily reference this in your function signatures. Now, this particular function doesn't have any return. So this is how we write a function signature without expecting any returned item at the end of the function being executed. I just hope you are getting it. Now that I hope you've understood what I'm talking about, this whole section is defining the traits, like the skeleton of your smart contract functions that you're going to flesh out later on. And once you're done with your traits, that means your interface, the next thing is to go to your smart contracts. Now, a smart contract is always housed in a module in Cairo Smart Contract. So this is a module called address example with the macro, with the label of the macro here, Starknet, the Starknet contract. Now, in this module, whatever libraries or methods, predefined methods you'll be using, you'll be importing into this to make it work, you'll still have to import them in this module. So here we import Starknet storage pointer read access, and storage pointer write access. I'm sure this is clear enough for you to understand what is going on here, right? Ability to read and write to the storage. And then we use super. Super, you know, in smart contract means something that is just ahead of the current block you're writing to, which means what we are trying to do is to import something that is just around here, right? So we are calling super one step outside this module. We are calling the contract address already called here and get caller address. Now, going to the contract proper, we have storage. Now, this storage is the struct that gives you access to the current storage, the storage of this smart contract. Okay, so you have your storage struct. I don't know if that is still the case, but every smart contract you write, every Cairo smart contract you write, you need to have your storage struct defined in it, whether it has any implementation in it, if you had any variables in it or not. You need to define your struct, even though it's an empty struct, because this is the storage struct. So it gives you access to the storage. And the storage, what we mean by storage here is once you have done, you've written your smart contract and you've deployed, it goes somewhere, right? And when you try to read and write to that smart contract, it has to read and write from that place it has gone to after it has compiled, you know, broken down and stored on the blockchain. You have to read and write from that place. So that is the storage where your smart contract lives on the blockchain, that you can read, you can write, you can get access to, you can do your edits, or you can just get a snapshot of what is currently there. So storage, that is what this is doing. And here in this storage, we have a variable called owner, and it's a contract address type. Okay, So this, when you see things like these are types, data types of how variables are being stored in your smart contract. So the owner is a contract address type. And so this is going to give us access to read and write to owner in this storage. The next is the constructor macro. In this constructor, just like your usual constructor, you know what happens when you deploy your contract, the constructor runs and everything is being compiled before it gets stored on the blockchain according to the structure your constructor takes. So this constructor is a rest of contract state. It is taking an initial owner. You know why it is a reference in itself, right? Because this constructor is going to edit, is going to change the state. Once you are, is going to set the state, and that first state it is going to set for this smart contract, it is a right action that is going on, and that is why it is referencing. Okay, so it is going to taking an initial owner contract address. Just give me a minute. Okay, so let me just finish this and then we'll proceed to something else. So for this constructor, it is taking this parameter of initial owner, because when you deploy your smart contract, you want to set the current owner, who is the owner of this smart contract, to storage. So once you pass this in your constructor, and then this is an implementation, self.owner.write. This owner is gotten from your storage. So you are trying to write who this owner should be. And then you pass in who the owner should be. That is this address you added here. You set it down. And then once this contract has been deployed, this owner here will automatically be this person's address you have written here. So that is what is going to happen. That is what this part is going to handle in your smart contract. Now, the next is for you to implement your traits, implement the functions that have been found, that have been written in your traits. And there you use this AVI embed macro to expose the functions you want to be made external and public, so people have access to interact with the smart contracts. And then it is enclosed in this block implement. This is the name implement. This is the name of the implementation. And what are we implementing? We are implementing this trait that has been declared here. And because it is outside this module block, you use the super annotation, and then it means jump one step out of this block and get what is here, and then the name of the trait, which is I address example, and then you write it here. And then here, where you are doing your implementation right now, you wouldn't add the T because it is no longer a generic trait in here. Here you are setting the contract state. All right, so the first function signature we have is the get owner, which we are going to implement right now. So you will get the same signature as it is here. Mind you, be mindful of the T. because it is no longer a generic um, um, implementation any longer. So now you are setting the implementation yourself. So when you do this, what is going to go in this body is the implementation. What do we want to happen when we call a get owner function? We want it to return a contract address. So you write your implementation. You are calling a read function. So we are going to read this owner to see what is saved and stored in this owner as the address. So this should be the result of calling this function. So when you try to read, you use self dot the owner dot read with the bracket. So this method is going to read what is stored here. And whatever you pass into your constructor and is stored as the first storage of your the smart contract after deployment is what will be read here, is what will be returned here. So whatever it passed here will be returned here when you call this function in first glance. Okay. Now the next function we have in our trade is the transfer ownership. So we are going to implement the transfer ownership, and then we're passing in a new owner contract address. So we're doing let caller, because we have to declare a variable caller. Let caller be the get caller address. Okay, and we assert that caller is equal to self the owner dot read. Only owner can transfer. So what we are trying to do here is we are making sure whoever calls this function is not just anybody, but the current owner of the smart contract, because we want only that owner to have the ability to transfer his ownership to a new address. So here we are certain that whoever is calling this function transfer ownership is who is stored here at that instance and not anyone else. If it's someone else that is not stored here, once it reads this and sees that this is different from this, it will return only owner can transfer. Okay, and once it reads this, once it gets the caller address, who is calling this address, who is calling this function, and it is equated to who is here, it is going to jump to this new line and it is going to transfer the ownership to the new address. And that is where we write self dot owner dot write, and then we pass it onto the new owner of the contract. Now, mind you, this is gated, so only the current owner of the contract has the ability to transfer the ownership of the contract to a new owner. So I'm going to check if you have questions or confusions, and if not, sorry about that. All right, so judging from this smart contract, this is an example of a simple smart contract. This is how a smart contract is to be written. This is a very simple smart contract, like I said, but this is how a smart contract is written. And I'm sure, seeing that we already have understanding of smart contracts, of what smart contracts are from our various fields, learning this, you see the similarity to what exists, maybe your current Solidity smart contract. You see that it follows similar guidelines. You have your contract written in a module or a contract, whatever name it is, but then it has a constructor, it has a struct, It has variables, it has importations that you import, and then you implement your functions. So I just saw that this might be a little bit high level for us or low level for us at the moment. So I'll be encouraging us to go through the Cairo book, understand the data types, understand what is going on here, understand data types so you can follow along. And then for the syntax, it's just this is Cairo is very, very typed. So for every variable, for every parameter, right, they are all variables, right? For every declaration of new variables, you need to specifically um, um, define its data type. So it understands what you are trying to, the type of result you're trying to get at the end of the day, or the type of data you're trying to impute into it before it processes. So you cannot just type in anything like JavaScript. You say x is equals to, without determining if that x is a string or x is an integer or x is a boolean, and it still goes through. It doesn't work in this context because you have to clearly define what x is and the type of data you're expecting X to return, type of input it is, and kind of output you will get at the end of the day. So I would encourage us to go through these data types. It is not complex. It is just the same with every other programming languages, and it's just the syntax that might be different. Okay, so just 1 minute. I want to speak with. I can see a lot of people leaving the call. Hope all is well. All right. So um, seeing we've dissected this smart contract, and yeah, this is the very, very basic smart contract. Like I said, very simple. It is just a read and a write, which you would majorly be doing in your smart contract. You'll be reading and writing a lot. So this is just a simple context, simple introduction to the smart contract. I hope we've clearly understood what these various blocks represent and what they do in your smart contract. So with that, I'll be going to my VS Code and we'll be dissecting some code. So I'll stop sharing this for now. Okay, so at this point, I'll be sharing this screen instead. Okay, so this is the smart contract that was initiated when I created a new project. We are all going to see that also soon. And I'm going to go through this again so you have proper understanding of what I'm trying to do. Now, this is a smart contract, and what this smart contract is doing is the smart contract is called Hello Starknet, and what it is doing, it helps you to increase the balance of whatever balance it is here, and to get whatever balance you have written. So it is just an increased balance smart contract that helps you increment the amounts. So what is going on here, like I said before, you have your interface where you declare your traits, that is your functions, the function signature of the functions you'll be implementing here. So in these traits, you have to name your traits, okay? And then you write the function signature. The next thing is you go straight to implementing your contract, and it is always enclosed in a module. And then you name your module, and inside your module, you create your imports. Here we are using the storage struct. Also, like I said, it is a requirement in your smart contract. Even though it is empty for a start, you need to create your storage struct. All right, so here, like I said, it's importing this library storage, and it is giving us access to read and write in the storage pointer. And the next thing is your functions. You are making them external exposed for the users to be able to interact with your contract. And then it is always written in an implementation block because you are implementing this trait over here. Excuse me. So for the first function, increase balance is a write function. It is a write function because you are changing the state from whatever it is. Mind you, if you look at this contract very well, you see there is no constructor in this. So when you call this balance, naturally it should return 0 because there's nothing in it at this point. Okay, and when you increase balance, it's a write function. That is why we are referencing itself. We're referencing the smart contract, and then we are passing in these amounts. We want to increase balance by whatever amount we pass here as a parameter. Okay, so here there is an assert. Assert is more like a require statement where you are requiring something to happen before you are requiring that something is true before it proceeds to the next phase, and if not, it shouldn't proceed to the next phase. Okay, so here we are asserting that amount is not equal to 0. So if amount is equal to 0, then it should return this. Amount cannot be 0. Then if amount is not equal to 0, then self dot balance, because balance is in our struct, dot write the current balance we have. Self.balance.read will return what we currently have, because what we are trying to do is increase the balance, right? We are not trying to replace the balance. So what we are trying to do is increase. So if there's something here, it should get that thing that is here and add it to whatever we passed in as a parameter here. We don't want it to replace what was here before with this amount. We want it to do an addition of this and increment. So if we write self.balance will write, we get the current state of what is here, which is 0 at this point because nothing has been called before. which is 0, or if you have called it before, it will be whatever you passed here, then plus these amounts you pass in here. So once you run this function, it should increase this balance to be what the previous balance was plus what the amount you set it to increase with is. So it will be 0 plus, if you pass 10 here, if you pass 5 here, 0 plus 5, balance should return 5 when you call balance. Okay, and then this function get balance is a read function because it is a snapshot of what is currently here. And because balance is a type of field 252, you are returning that field 252 because you're returning the, is someone trying to speak? Okay, so you're returning what is here. And so when you call this function self.balance.read with the parentheses, it's going to return this balance back to you. And this balance will be a field 252. Okay, so this is a simple incrementing smart contract that just keeps on incrementing the figure that is saved in the storage. Okay, hope this is clear. Yeah, it should be very simple. Okay, yeah, I just hope this is clear. So I'll be starting up a new project, which if you haven't understood how to set up a new project, please just go through the Cairo book. Yeah. Okay, go through the installation. Let me just go through it like, these are the installation, just in case you've not done this before. So you can get guidance here to help you to set up your system so you can start creating your smart contracts. Okay. All right. So back here, I am going to close all this so don't distract here. So I'm going to create a new hope this is readable and seeable. I'm going to create a new folder, new project called so I'm going to set it as a Starknet, Foundry default projects. Okay, so it doesn't want, yes. So when you are naming your Starknet, your Cairo folder, you might stumble upon this error. So it doesn't want a capital, uppercase character in the naming. Okay, so I'm going to do that again. So in case you stumble upon this, it's not it's not bad. It's not a serious bug. Just rename your project without adding uppercase and you're good to go. All right, so this is set up and I'm going to open this package. Oops, sorry about that. Okay. All right, great. So I've created a new project. Let me run you through this very, very briefly. In this folder setup, you have your SRC, and I am sure you understand what the SRC means. Your source folder where your main logics are written, right? Your whole code base is being stored in your Cairo code. So similar to Starknet or Cairo Smart contract, the SRC folder is what holds your logic for your smart contracts, your various logic, whether one file or multiple files or multiple folders, you know, as large as your project the folder will get that large as your project gets large. So every of your major implementations and all of that is stored in your source folder, SRC folder. You have the test. The test folder is where you write your test for the files you have stored in your SRC. So if you write your smart contract, this test folder will be where you write the test logic to test your smart contract instead of writing your test inside the same file or the same yes, inside the same file with your smart contract. It is good to separate concerns and write your test over here. So for each of your smart contract, you generate a test file for them to test that everything works well with it. We all know what the git ignore does, right? This is what you are ignoring and don't want to get pushed to your GitHub repository. Yeah, so the scarp.log, it's more like when you are dealing with your packages, whatever package you have set up in your system, in your project, sorry, with the versions of those packages, the scarp.log file logs those versions to prevent alterations and all of that. So it's similar to package.json and then package log.json. All right, so we have this the TOML file. This is where all your importations, like your packages, the metadata of your project is stored, your dependencies, just like your package.json. So everything you'll be using, toolings, you'll be needing would be specifically stated here. Now we have the SN Foundry.toml that handles, your testing environment, and all these are just some of the importation dependency and whatever packages is used and versions, the version controls of all those packages and all those setups being done here in your SN Foundry.toml file. Okay, so with that being explained, this SRC, you have this lib.cairo, and this lib.cairo, we have a snippet, a code snippet, which is the previous increase balance code snippet. Now, you have this file called lib.cairo. When your project, with this, it works, right? If your smart contract is just maybe one, it works. So if you test it, it's going to run. But when your project gets bigger and then you find yourself writing two different smart contracts in two different files, three different smart contracts, a lot of files, then this lib.cairo can no longer, it won't be advisable to house this in your lib.cairo. You have to move this out. If this would be a contract you would use, you have to move it to a different file. create a new file and pass this there. And then your lib.cairo will give access to all the smart contracts that will be written under this SRC. So what it will hold is the modules and their names, so you can always access the various smart contracts in this folder. So now I'm going to run, since there is already an example test written for this contract over here. Let's go over the test before I run it. This test over here, I will not do so much on the test because there's a separate class for test. So it is importing the contract address, it is importing SMForge STD, it declare contract class trades, declare results, and then it is importing all these from this lib.cairo. These are like the trades and methods that are found in this lib.cairo. It is going to import them here so you can use them to write your tests. And then it does the deploy contract part where you deploy, even though it is to a test blockchain. In this test, it deploys an instance of the smart contract so you can test all your pre-written tests on the smart contract. So this handles deployment, okay, in the test environment. Now, when you're declaring your test, you add the macro test and then the test logic. The test logic is you get your contract address, which is after you've deployed. So it is going to call deploy contracts and then the name of the contract. And then it goes through this method to deploy a test environment blockchain for these projects, and then gives you an address you can interact with. And then you write your logic. So these are various logics, testing logics for the smart contract already written. Here it is testing that the increase balance function works as expected. What it is doing is it is getting the previous balance before here, and then it is asserting that that balance is equal to 0. You know, upon introduction, upon setting up the project and deploying it, there's no constructor and all of that. So there's the balance before, the previous balance in your struct, your storage should be 0 until you call this increase balance function in your smart contract. So it should be 0. And if it is not 0, then it should return invalid balance. And then after that, if it is 0, then it should run this next line. It should increase balance to 42. And then you say let balance after. Balance after means after it has increased, you want to get the new balance. You get your new balance and then you assert that balance after is equals 42. Else it should return invalid balance. So we are going to run a test to make sure that this works. And then this is a test to check that what when you're trying to increase the balance, you are not just using a 0 value and you want to increase balance with 0. So it checks for that 0 value and returns an error if you try to increase the amount with 0. Okay, so we are going to run the test. I just hope my screen is visible and the write-ups are clear for you to see. Yeah, okay. So we've run the test, and please, is this screen visible?
It is visible.
Okay, thank you. So we've run the test, the predefined test, and we are getting 2 tests passed. The first test it's not increasing with zero value passed, that means the logic works correctly. And the next test to check if it increases balance also with 42 also worked. So it means that the balance has actually increased with 42 when it ran the second test. Okay, so another thing you can do is, let me see if this would work. If you really want to see what the balance actually is, you can print. So I'm going to try to print, and because I know the balance should be 42, I'm going to type a string to return balance is 42. Okay, so I don't want to do too much here, but I want it to return balance is 42 because this is checking that balance is 42. So if it truly is 42, then the trade balance is 42. Although you can also save this balance after and also call it in your print statement, but I don't want to go all that route today. Let's just do this. So when we run this test, we should see that our balance is 42. Okay, so we can see that after running the test, it shows that balance is 42, and then it passes all these tests. Now, testing is very important to be sure your logic works exactly as it should. Okay, so after checking that, the next thing is we are going to change this folder, this directory setup, because you would be dealing with more than one file in your smart contract in your source. So it is not advisable to stick with this lib.cairo, having your logic in this, but saving your logic in different files and then referencing them in the lib.cairo file. So I'll be creating a new file called increase hello Starknet dot Cairo, and I'll be taking everything here and passing it here. Okay, so the next thing I'm going to do is in this lib.cairo, I'm going to create a reference to it. So because this package, this file exists in this SRC, you see the red squiggly lines disappeared. Now in this test .contra.cairo, because I have changed the import, it is no longer just getting from this lib.cairo, but now it's fetching from hello Starknet. I have to add the import part correctly. So I'm going to, hello Starknet. So this should work. And so the mode is not visible. So let me add the public here. So if you noticed, it told me that this hello Starknet was not visible to this because I did not add the public before the mode. And so I added this to make it visible to this file. So you can see that it works correctly now. So with this, you can try to run the test again. And once you run the test, it should work perfectly because everything is in sync. So when you create more folders, when you create more files, you keep adding their you keep adding them to your lead.cairo. So as you create more files here, you keep adding their names over here so that it reads those files for you when you are trying to run whatever you're trying to run, the test and the compiler here. Okay, so that is about your folder setup and structure and how it should look and all of that. So let us create a smart contract from scratch, or hope this is not confusing to anyone. Let me just quickly check. Okay. I just need a show of hands, thumbs up if everything is going well. Are you guys following? Oh, great. Great. Thank you very much. All right. Thank you very much. So we are going to create a new contract, and let's just call it storage. Storage would be, it will still be like this. Maybe register. Okay. And here we are going to create the register. Excuse me. Okay, so we are going to start with the register. We are going to start, like I said, with the interface. So you write your traits, and then whatever name you want to call your traits, say I, because it's a and then referencing C contract. Okay, so you want in this register, you want it to register a new student or a new person into the program, and you want to also read from this list of registered persons. So we can create various functions as touching this register. So first, let's create the function to register. And because it is what I said, because it is a write function, you are referencing, right? You're going to reference and then what should we take in? We can take in name. We can take in name, and name BFL 252. So like I said, whatever variable you list, you have to add its data type. And then we can also take in the address. Now this address will be a type of contract address. So we are going to have to import this from Starknet. So at the top of our file, we're going to do this. So we are going to register. Once we register, we're going to get the passing in the parameter of name and address. Maybe we want it to, let's make it return something. Let it return a Boolean. So we see that it has successfully registered someone. And then let's have a function. Excuse me. Okay, so let's have a function called lists. So you can view the registration has happened. So the list should hold the list of or let's just call it get first before we go that intense. I don't want to do so much today, so you can go over this. But we'll be building on this simple register in next class to make it much more verbose and taking much more things. So here we just want to get the register, what has been stored in the register. And then so we have to, what is going to return? What is it going to return? We want it to return this register, right? But seeing that this register is a complex type of data, because taking in two parameters, and we want to see almost everything that has been stored in the register, we might have to create a struct for this register to hold this data, right? And then once we create that struct, we can reference this get to that struct that has been created for this data. So in order not to confuse us so much, I will be going to the Cairo book because I want you to leverage it so you can see what I mean there. Excuse me. The Cairo book, it's a site. This is let me get the link. So I'm going to drop the link here. So you can visit this book and go through, just set up and started in your Cairo Starknet journey. Okay, so excuse me. Let me quickly go here. I just want to show us struct. That is if we haven't gone through structs. Sorry about that. Okay, let me just go through the smart contracts. Okay, so I think this is going to explain what I'm trying to do, I think. Yeah, so this is okay, this is a mapping, and this is how a mapping is declared in Cairo map, and then you pass in the key and the value. So whenever you pass in this, you should return the value for you. And I'm trying to see where, sorry about that. Yeah, so this is a normal struct. Now this struct is called user, and these are the various variables in it. Now, if it's for storage, it will have the macro on it called storage, but this is a normal struct defining a new data type in your project. So you can use this to house lots of variables in one body called the struct. So when you are trying to return a particular item that is a struct that has different variables, you can just reference this name as your return item, and then it returns these with whatever is stored in it. All these values already instantiated, all these variables, already instantiated in it. Okay, so this was what I was trying to explain. Let me see if this is a contract. Yeah. So this is something you can use. This is how you can implement it. You can add values to all these variables in the smart contract. So I want to I want to define this in my smart contract. So I am going to declare it later on. But for now, let's just return let's see. Let's return a field to 5. Okay, so we are done with our traits. And the next thing is we're going to implement our smart contract. So it is going to be a mode called register. And then, sorry, what is going on? Yep. So it wants me to declare the storage. So as you can see, you can see that it kept on complaining until I created the storage struct. So this is very important in your smart contract. So I'm just going to get these this and import it here because I want to also read from this. Okay. Yeah, I would use you soon. All right. So we are going to create a struct, like as seen here. And in creating a new struct, you have to add this macro. to it to differentiate it from your storage and for you to be able to use it. So we call the derived drop. And then we call these structs called register. Let's add the register struct to make a difference. And in this struct, we are going to take a name, which is spelled 252. And and then we're going to take in address, which is a type of contract address. So I need to import it also here. Okay, so I have this struct that is going to take in a name and it's going to take in an address. So what I'm trying to do with this struct is anytime I click on, I call this register and the passing this name, passing this address, I want it to get stored in this struct. I want it to get stored in this struct. And anytime I call get, I want it to get what is stored in this struct. They have a question. Oh, cool. All right, I want it to get what is stored in this struct. Okay, so now that we have declared this, anytime I call get, I would want get to return this for me. So it's not a spell 252, but I want it to return the register struct. Okay, so this is not here. Let me see if it will work this way. Let me make this a public. What's going on? Sorry, let me quickly check this out. Importation is very tricky most times. So I'm having an issue because I'm trying to import from this mode out here. Sorry about that. Mm, let me try this. Okay. Okay. Why is this complaining? Oh, okay, I think we are good. It's complaining about implementation. So we haven't gotten to implementation yet. So when we get to implementation, hoping this is going to get sorted. All right, so I am calling the register struct here because this is what I want to get returned anytime I call this get function. Okay, so I'm going to go straight into the smart contract. I want to see if there's anything I missed. Okay, so we're going to expose our functions. So use this ABI embed, make your functions external. And then we're going to implement and call this register implement of, we are going to implement these traits. And now, because we are implementing it, it's no longer a generic. It's no longer going to be generic. And so we will be including the T for this. And then we are going to just copy this. So clear this, then turn this to curly brackets. And then this will be a contract state, no longer T contract state, while this will be the register struct. It will be returning the register struct. Now, before I come here, when this struct is finally implemented, once we have someone register and then it gets stored to the struct, I want it to get saved in storage here. So in this storage, I can have a mapping. I can have a mapping that returns stored variables, stored items in it. So it can be a mapping of maybe we can just pass in the contract address, or we can pass in maybe an ID, and the ID will be, let's just use felt 252 to provide, and we want it to return our register struct for us. So when you are including a mapping, you need to create your imports. I'm sorry if this is seeming too complex. I'm adding so many things, right? Guys, guys, are we following? Is it going well?
Uh, we are not following, the,
Okay.
we are,
So
we are not following, please.
I don't want to just keep going without you guys following. And I
Um,
see you're adding so much things to this, and I want to be as simple as possible for this first class. So let me know where the challenge is coming from.
Please, let me ask, like this thing you have been learning since, you haven't shown it like on the interface, like where it's being shown, like,
The
so,
interface.
yes, yes. Like you have been learning programming language. Like how does it work on a site?
Okay, so the
Yeah,
interface is like your like a structure of the data types you'll be using and the output you want. So you are trying to define the type of input and output you are expecting from something. You're creating a kind of skeleton of that thing in your interface so that when you want to use it later on in your smart contract, you are just referencing what you've already created. Okay, so you have
Uh,
interface in almost different lots of programming languages.
sorry,
In those
sorry, I
interfaces,
think that's not what he's talking about. If
okay.
I got it clearly, he's referring to, like, just like the way HTML, you can see a visual HTML, like where it's being used, and probably like JavaScript, all those things, you can see it visually and where it can be applied. So he's trying to like say that you've not shown any place where, like, how it can be used or how it can be consumed. That's like the interface he's talking about, not like the type of the interface type.
Um, do you mean like the front end part of it? You want to see the visual?
Yes,
yes,
that's what he meant.
yes, my
So
boy.
that will be
Yes, ma.
handled in the front end part. Right now, we are dealing with the smart contracts.
Yes, I
The
understand.
only way you can see that your functions are working perfectly in your smart contract is to write the tests. And that was why I went through those tests. So you can see what those tests returned in. And those tests were testing the functions that were written in the smart contract. And those functions were in the traits, right? That is the interface.
Yeah,
So once the body has been implemented, let me go to this one here. This is the function signature. This is the trait that we'll be using later on. And here inside the implementation of this, we were able to implement this function and write the body for it. Now, in this test contract, here, this is a test. We are testing our functions to make sure, to ascertain if the functions are working perfectly. Okay. And here we tested the get balance part of the function, which is shown here. So when you call this, you want it to read from here and return whatever this balance is, right? And so that was what we did here. And then we stored it somewhere. And then we now called the increase balance. So it will, and we passed in the amount we wanted to increase with, and then we populated the function, and then it ran. So after you call this, and then you call this, you are expecting that balance should increase to 42, right? Yeah.
Yeah.
So we have the test to ascertain that balance is currently 42. If balance is not 42, you should return an invalid balance. Now, because we have no, like, there was nothing visual in the terminal showing the 42. I wrote this, so you can use this for like debugging sake and just to see what is going on, that everything is working fine. When we run the test, which I'm going to run, okay, so you can see here, when we run the test, this is what it generated for us. The first test, to make sure this balance is not zero, it's not increased with a zero value, it was successful. And then the test to test this increased balance, you can see the name of the test here, test increased balance. It also passed. So this is going to give you like an overview that your functions are working well. So you have to be liaising with your how do you call this now? You have to be liaising with your
Terminal.
now to see what is going on for now until you integrate the front end and you can test and see it on the front end side of things. So I added this line because this code is going to break. This test is not going to pass if balance after is not exactly 42. So since I am expecting this balance after to be 42, I wrote this line, balance is 42. And then in this, when I ran the test the second time, you can see it here, it returned balance is 42. And then the tests that were written all passed. So you can use this method that I used here to give you like a visual view of what is going on in your functions. Okay? Until you integrate the front end to it. Is that fine?
Yeah.
Okay, cool.
Thank
So
you, ma.
yes, you're welcome. So I was trying to add the mapping. Okay. So I was trying to add the mapping. So here, this is how you add the mapping. Okay, so I need to add this to my Starknet storage. Okay, so the error has cleared. So I've added the map. I want that once we pass in the figure, whatever this is, it will return this struct to us. Okay, so here I'm going to change my get so that we can have something like an ID. So we can pass it anytime we are trying to return from the mapping. I'm wondering why this interface, okay. Themes, it has not sent this. I'm wondering why this has not been, I'm going to get this for the next class, why this is giving us a challenge here. All right, so I have defined this, I've defined this in my implementation. So here I'm going to implement this register. So we want that whenever anybody comes to register, it should store their name to this name here and the address to this address here. And we also want the we also want it to have like an ID, right? We want it to have an ID, store an ID for this process. So once we are trying to get, we pass in that ID and we can return the particular struct for that particular ID. So we are going to we can do this. Because there's an ID here, it's giving, let's see. Okay, because we've not used it yet. Now, what we are going to do is that we are going to call this struct. In the previous part, I showed you how the struct is instantiated. Let me go over it again. Here. So you can use this method where you call the name of the struct and then you pass the various values of the struct to that struct, to the various variables that are saved in the struct. So this active is bool, this username is byte array, this email is byte array, this sign-in count is UID 64. So you can call this. So here you are instantiating it. You say active is true because you are now adding the value to these variables. So active is true, username is whatever the person's username is, email is whatever the person's email is, and sign-in count is a felt or is 1, right? Because it's using a UID 64. Now this is a UID 64. This is an integer. Okay. I am using felt 252 here. It is not the case. So let me change this so we don't even start with this. Let's use numbers because this ID is definitely going to be a number all through. So I can use a UID 32 for this ID. And let me correct myself here. A felt can also be used. A felt is the general data type of any variable you declare in your Cairo programming. It's if you declare a variable without specifying its data type, it will automatically take in a data type of felt 252. Felt 252 is the longest or the largest data type. It can house up to 32 bits of data characters in it. So it is the largest data type in Cairo, but you can use some bytes array type of different felts joined together for maybe longer data types. So if you are writing a sentence or something like that, you can use byte array. A byte array is an array of felts, of different felts. So it is still using felts. Felt is the largest data type. So it can house some of the biggest data in your Cairo programming. So you can take in numbers, characters, strings, and all of that. But ID is a number, so let's stick to number. Integer, sorry. Okay, so I think I'm going to add an ID here too. So we can use this. So it is going to use a uint32 to return this struct to us.
Naming that tune.
Sorry about that, guys. All right, so we are going to call this register struct. Let's see. Registered, and we are referencing this register struct. And what we are going to do is name. We are going to pass this name over here to this name. Okay, so because they are the same naming convention, let me add an underscore. Oh, sorry. Sorry about that. Am I still connected? Can you guys hear me,
Yes.
please?
Yes, you can hear
Okay,
you.
thank you. So I'm going to add like an underscore to this to differentiate this from what we have as parameters over here. So name is going to be name that we get as from this parameter, and then underscore address is going to be this address, and then ID let me do this. ID should be this ID. So let's make ID 0 here first, then subsequently we change it. So once this has updated, once this has been, sorry, what's going on? There's so many errors popping up. So once we have done this,
I think
yes,
you didn't complete your break function. Probably that's why
sorry.
below. I think you didn't complete your get function line at 6. That's why the errors are coming.
Yes, okay. All right, so once we've done this, yep. Yes, Chukobed. Okay, so once we have,
Okay, ma.
okay, yeah, please.
So
Yes,
where I'm kind of confused is this place that we have two ID. The letter ID equals to 0. Then where you wanted to pass the struct data, you're also
yes.
setting 0. So
Let's just do 0 here. So let me remove this, avoid confusion for now.
okay.
I'm going to put it here. Okay, cool. All right, so the next thing is to instantiate our storage, our mapping. So we want to write to this list. And to write to this list, what we are going to do is, after doing this, we'll say self.list.write. So in this write, we are going to pass into items, right? We are supposed to pass in this ID and pass in this particular registered struct of this particular person. And so we can, for now, since it's just 1 and this ID is 0, we can just pass 0, and seeing that it is urine 32, and then the next item is taken is a register struct, which is this registered, and pass in registered. Still, see, something is going on. And then after everything, we can return true, because this is what we want to return after the when we call this function. So let me just quickly check what is going on here. Create has no implementation in context, and the storage is not mutable. Okay, sorry, let me check out this error. Let me quickly check out this error. Going back to the Cairo book. Okay, yeah. Okay, I think I get where I'm having this. So, what else am I calling that? Sorry, guys, I'm trying to figure out why I'm getting this squiggly line on the right. And I'm trying to call the right function. Let me see what's going on here. Sorry, I think it's in the mapping. I think I'm meant to wrap this bracket twice. Let me just quickly see here. Okay, maybe I'm supposed to use this method seeing we are using the mapping. Let's try this method with the entry caller since we're using the storage path entry. Yes, Obed.
Okay, ma. So on the register struct, let's try to add a store macro on the register struct.
Okay.
Yes, there's this one article I was reading, or something like that. So on the register struct, we just add the store macro inside the drive method.
Well, this. Okay. So let me see. Let's create a caller. Whoever is calling this contract. Let me import it here. Yes. Something is wrong, totally wrong here. Sorry guys, I'm trying to figure out why I'm having this error. So expected, wait. Sorry guys. I have got this, imported this, and I'm wondering why I'm getting this error right now, even with all this added. So I don't want to waste time on this. So let me just go over what I've done so far. Then in the next class, we are going to continue from here. So I can answer your questions quickly because we are already out of time. So this is what I'm trying to do here. In this register function, I am trying to get in the name of whoever registered and the address. And what I want it to do is it should create a separate document for that person, and I'm instantiating it with a struct. In this struct, I want it to save the address of the person and the name of the person, the address of the person, and this ID of 0 to that person's name. But with this method, all the IDs will definitely be 0. So we are going to change this in the next class. But I was just trying to explain to you how this can be instantiated. And then after instantiating this struct, what I'm trying to do is to push this struct to storage. So once I push it to this storage, which is a mapping of uint 32 to the struct. So it will push this person's information to this list. So anytime you call this list, it is going to show you the list of every person that has registered from storage. We want it saved to storage. Okay. At this point, it is not yet saved to storage until this is called. So we want it saved to storage. So we want to fetch, read from this storage and write to this storage every new person registered. So that is what we are trying to achieve here. Okay, so that is why I used this struct method in order to explain what the struct is, how you can use a struct aside using it for storage, but using it also to store normal values, and then using a mapping and then instantiating the mapping from storage here. And this is where we had the issue, which will be rectified, fixed in the next class. because of our time. And also, this get function is to read from this storage, from this mapping of list, and return what is here. But in the next class, we are going to add one more function. This function to get according to ID, so it will just return a particular student information or a particular registrant information, and then would have another function that returns all the information in all the registered persons in this list. And in that functions, we are going to do some looping method in order to return all those that have been registered. And it's already 10 p.m. So I'm going to take all the questions now, and we'll continue the rest in the next class. So thank you, guys. But so far, hope you guys are not confused about what we are doing. That is my major concern. Hope is it clear?
Yeah, thank you so much. Thank you so much.
Okay.
That's great.
Yeah.
So it was an amazing session. Yeah. So guys, if you have question, right? So just take a couple of minutes. It's just exactly 2 o'clock. So if you have any question or any concern for about what the mentor has been talking about for the past 2 hours, please kindly raise up your hand. If you have, no matter the question, right? Kindly raise up your hand and ask the question. Please kindly raise up your hand and ask the question, no matter what it is.
Mhm.
Right. The mentor is just like answer a question. If you have any question at all regarding what is taught today, or you may probably last class, right? You can please raise up your hand. Or we all understood what she has been talking, she has been teaching about since past 2 hours.
Okay, I think they are good. So just go through the Cairo book, the link I've dropped, to understand some of data types and references and mutability and all of that. And I'm also going to leave this code exactly as it is and continue from this in the next class. So we debug it together and you see what I did to correct the errors. Yes, Olisa Tech.
Okay, alright. So I just want to say thank you for today. But the thing is that, and what you have been teaching, like I didn't get to understand everything, and I haven't started practicing it yet. So maybe after today's lesson, I will start practicing it.
Oh,
So what if we face any issue, like how these things, like while practicing it, like
so you can bring all your questions, right, to the next class, which is on Thursday, or you can get access to me. Just reach out to Ken. Also, he has posted my Twitter handle. He has posted it on the official Twitter page. So you can easily chat me up. I'm like very active there. So if you have any challenge while going through the class and reworking it, you let me know. Or you can wait till the next class and then we handle it there together. Yeah.
okay, thank you.
Thank you.
Yeah, all right. Thank you so much. Yeah, so I understand that a lot of people have network issues. Like a whole lot of people have network. Just I don't know why Airtel decided to mess up today, Sha. I noticed that a lot of people have network issues. So what I will do is that I'll try as fast as possible to get this recording out to us this night.